Everyone, and welcome back. We're Dan, Nicola, and Vlad Iliescu, and together with us we have Thomas Sundberg, Principal Consultant at ThinkCode AB. Hi, Thomas. Well, Thomas is, as I was saying, has more than 25 years in software development, and he specializes in software craftsmanship, clean code, TDD, BDD, but also test automation and continuous deployment. And in his talk today, you will see battle-proven examples for creating good software architecture, good and testable architectures. Yeah, because the unit tests should be fast, reliable, easy to write, easy to run, because otherwise nobody's going to run them. That's what I heard, at least. Thomas, can you confirm? Have I got it right?
I did not hear all of what you said, but the parts I did hear, I can definitely confirm that the goal here is to make sure that we get just reliable and relatively easy to maintain. And I hope my video is coming through properly. I just got a message from Zoom that said my connection was unstable.
I think now it's picking up, so now it's okay. At first there was some small glitches, let's say, but now it seems good.
Okay, let's hope for the best. I guess I should share my screen.
Yeah, let's get the show on the road, and then as usual we're gonna come back with questions towards the end.
Yes, okay. So I hope you can see a presentation. How can I hide the speakers view? Hide thumbnail videos. There we go. Okay, so I am Thomas. I'm based in Sweden. Doesn't say that here, maybe it should. Anyway, I'm here to talk about testable architecture. And you did get a brief introduction to what I do. And so let me just repeat what I do a little bit. My main focus is to deliver software. I'm a developer, and making sure that people are able to use the software is very, very important to me. I'm also very into implementing it. That's why I'm here today. So test-driven development, behavior-driven development are two really important concepts for me. They are very similar in one way, and they're a little bit different in some other ways. Clean and maintainable code, yes, very important. I do some mentoring, do some teaching sometimes, and I have also been doing too much DevOps, and I'm not even sure what that means, but I do whatever it takes to get stuff delivered. Yeah, so that's pretty much me. Software in production, and some people they're happy when the unit test passes. Some people are happy when the documentation is written. I want it to be in production, and I also want it to be used by real users, because up until that point we have no idea if we made the right thing or if we made the wrong thing in the right way or whatever. We can't get feedback from anyone unless it's used by real users. I also own a couple of trombones. Occasionally I'm playing on them as well. So that's me in the middle playing the melody on a tune that I don't remember the name of at the moment, with a big band. And it's very seldom that I'm the one playing the melody, but it happens. It happened that time. So this is a concert some years back. So software, there are otherwise won't be able to do the correct thing. We must be able to implement the correct thing with confidence. And finally, we must make it available to our users. So that's the goal should be the goal for most software developers, perhaps even all developers. Today, we're going to focus on one part, and that is implementing it with confidence. So making sure that whatever we are implementing is implemented in a good way, and we know that it will work. We won't be woken up in the middle of the night by some angry person calling us and saying that it's broken. At least I don't want to be woken up in the middle of the night, and I don't think anyone wants that. So ask ourselves, how do we create confidence? Well, something has to be trustworthy. We have to be able to trust it. What does trustworthy mean? Well, I looked it up. It's an adjective, and it is similar to reliable, dependable, honest, honorable, upright. Trustworthy is something we can really depend on, something we can trust. So we can create confidence that our system works by making sure that the way we work and the way we do stuff is trustworthy. It's worthy of trust. And how do we know that the program is trustworthy? Well, there's only one way that I know, and you test it. And that leads us to the question, is everything testable? And that's a hard one. A lot of things are testable, but it's not necessarily easy to test everything. So one thing that we have to be good at is making sure that we can test things without too much hassle. And therefore, we need an architecture that makes the world a simpler place to be, that makes testing something that is simplified. It's not easy, but it's easier if we do it in one way or another way. So a testable architecture, that's my goal here. And just to make it clear, I want to talk about a lot of things today: capacity, load testing, penetration testing for the security folks. There's a lot of things I will not talk about. I will only talk about functional testing today, as in, if we call this method, given these things, will we get correct? Will we get the correct answer back? So functionality, nothing else. Some of them are hard to test because things are interconnected somehow. Some of them are easy to test. And one question is, why are some architectures hard to test? Well, it's always a culture problem. Testing isn't a first-class citizen. So the folks who came up with the ideas on how to connect things, they perhaps didn't even think about testing. If we have any Java developers around, you might remember Enterprise Java 20 years ago. We got Spring because Enterprise Java was too hard to test. But testing isn't a first-class citizen in many situations. And some people see testing as somebody else's problem. So there's a tester perhaps that will take this program and make sure that it works afterwards. And yes, we need testers, absolutely. But their job is not to test our software and make sure it's not fundamentally broken. We have to do that ourselves. Their job is to look at it from another angle that we missed, perhaps. Working together with a good tester, that's fantastic. I've done it a couple of times, but they are not the people responsible for quality or anything like that. I am responsible for the quality, as I am the one who implemented it. Okay, why are some architectures easy to test then? Well, again, culture. Have a culture tests is the first citizen. Testing as an activity is a first-class activity. This is something that is looked good upon. People don't look down at you as because you're doing some testing. I'm aware of people that actually don't think that testers are that valuable, or that testing is boring and therefore they don't want to do it. That's a very bad approach, or very, very bad mindset. So sometimes it's easy just because we think that testing is a first-class activity, and we have accepted that testing is your problem or my problem. It's not somebody else's problem. And you use tests to drive the development. If you do that, then testing is definitely first-class citizen and a first-class activity. And no matter what people tell you, remember that it's always a people problem. Every problem in computer science is a people problem, if you look hard enough at the problem. Right. And a testable architecture. It should support a couple of things. We must be able to create confidence that the thing actually works as intended. We need short feedback loops, and it can't be too expensive. So these three properties, confidence, short feedback loops, and low cost maintenance, are very, very important. And how can we achieve all of these at the same time? Can we achieve them at the same time? Well, the thing is, you can't have the cake and eat it, because when you have eaten the cake, you don't have it anymore. So if we have these three things, confidence, speed, and low cost, then we can have confidence. But if we have confidence, we probably can't have speed or low cost. If we skip the confidence part, we can get something very fast and rather easy to maintain, so it's not too expensive. But we can't have all of them at the same time. Sorry, it doesn't work like that. Because sometimes the thing that really creates confidence isn't fast enough. You can't run them too often. So how can we sort this out then? Well, we want to try to get the best out of all out of these three properties. So can we combine these? Yes, we can, and I'm going to show you how. Let's look at the testing pyramid first. It's very slow to test the system through the user interface. It's very fast to test it using unit tests. It's very expensive to test it through the user interface, manual, or you can automate things. If we look at the web system, for example, we can use a tool like Selenium. And it's much faster and much more predictable than manual testing, but it's still slow and rather expensive. We would like to use more unit tests if possible. So in order to do that, we need to take control over the world. We need to make sure that any dependencies we have are properly configurable. This means dependency injection. But let me be clear on this point. It does not mean dependency injection systems. We don't need tools like Pico Container, just to mention one dependency injection framework that you probably haven't heard of. We don't need Spring, but we need two dependencies. So the way I tend to do it is through the constructor. I create a constructor that allows me to push everything I need into my classes. So if a class needs a collaborator, I will supply it through its constructor. So let's look at an example, and let's look at a to-do list. We have two things that are really important. I think you could come up with more ideas if we really thought about it, but two things that we need to be able to do to have a to-do list that actually seems to at least maybe work a little bit. We need to be able to add tasks. We need to be able to find the tasks. And you might want to mark them as done as well, but that's for the next iteration. So let's look at an example, the one where Thomas remembers to buy cat food. This is a very important task. As these guys, these are my stakeholders, they will be very upset if there's no food around. And the one looking at us is My. She's a little bit afraid of my partner with the camera in this case, because she's very shy. The other one, that's Gretchen, and she's very hungry. She don't care about anything. She's hungry. So these are my stakeholders, important parts of my life. In this case, a to-do list. It needs a collaborator. It needs a database, because otherwise my task will be gone when I run. So I need some persistence. And I want to configure them. So how can I do that? In my to-do list, I will push the dependencies into the objects that needs a collaborator. So in this particular case, I will have a constructor, my to-do list service. It will take a database as a collaborator, and I will make it available to anything that needs the database in this service. As easy as that. But when I have this, now I can start testing this one, and I can start testing it from many different with many different aspects. So I can write a test that will verify the to-do list service, and it could look like this. I can, if I want to, mock the database. I need it, of course, otherwise I can't verify it. The to-do list service need a database, so therefore I start with creating a mock. Then I create a task. A task has an owner, and there's something I have to do. And the to-do list will just accept an owner and a task. And I can verify that the database has been called with this these two arguments and this method. So this will be able to help me make sure that the add task actually can be implemented using test-driven development. This could be one part of that, one step in my test-driven development process. And I can verify that I've been adding a task. I can do the same thing for getting tasks. So I will create a mock. I will create an owner, and I will create my to-do list service. Then I will ask the to-do list service, could you please give me all the tasks that Thomas has? And I can see that the database method called getTasks has been called. So that's great. I can verify that things are being connected to. So this is good. However, it's just mocks. Come on. Do you trust them? I don't. Not always, but sometimes. But it's fast. That's good. And it's not too expensive. So 2 out of 3. Really, that's not bad, is it? That's like 67%. Good. Okay. So let's see if we can build upon this and create something better. So I'm able to that the database. I'll be able to verify that the database actually works as expected. Because I have a mock that verifies that it can be called, but we have no idea if it works or not. The database is very slow, so that's a problem. So we want to be able to check the contract, because contract testing can be very fast. And we want to verify a real database, which could be, I don't know, a Postgres database perhaps, and a fake database with the same test suite. If we can do that, then we can say that the real database and the fake database is equal from a functional perspective. And if that is true, then you can trust the fake. And the fake can be very fast. Okay, how can we do that? So my plan is to implement the database as an interface, a Java interface in this example. I will create a proper implementation, an implementation that connects to a SQL database somehow, but this one will actually use a proper SQL database. It won't be a fake. But I will also create a database. Favorite the list with items. That's my favorite way of creating my in-memory database. And the reason for that is that they're really fast. So if I combine these things, then I can probably get confidence by verifying that the SQL database behaves in a certain way. I can get speed and low cost by verifying that the in-memory database behaves the same way. So it has potential. This could be good. So let's look at the test. So this is a test where I should add a task, and there are two things you would want to ask yourself here, or maybe three. Who is Malin? Malin, she's my partner. And what is Mintu? Mintu is a Finnish specialty, very minty liquor. And where do the database come from? And that's the most important part here. Where do the database come from? Well, it just exists. And this is Mintu. And if you haven't tried it, you get a chance. You might like it. I don't know. Never mind. So this is the test we'll use. Let's notice a couple of things here. The database is a field. We still don't know where it comes from. It's an abstract class. This class cannot be executed as it is, but it can be inherited. So if I were to implement a test class that inherits this one and somehow create a database, I could run this test. So using inheritance allow me to verify the real database and the fake database using the same test suite. And this will give me confidence that the fake is as good as the real thing. So an in-memory database test looks like this. It extends the database test. So therefore, all tests that are declared in the database test will be executed. Right, database, a fake. I will also implement a SQL database test that extends the same thing. But the difference here is that it creates a SQL database. So we have a fake and we have a real thing here. And if I run both of these and I get this very same result, then I know that for that example, they are functionally equivalent. So again, I get confidence with the upper one, I get speed with the lower one. But I also get confidence that the fake will behave the same as the real thing. And that's good. Because now I can write an acceptance test that will verify the to-do list service. And it could look like this. Should remember to buy cat food. All right, so I have a database, but now it's clear that I have an in-memory database. I have a fake database. I push it into the to-do list service. I create the owner and I create the task. I add things and I get run it and I get the things back. So I can verify that the two things that are important here, add tasks and get tasks, works, because the result here, my actual, I don't have any line numbers here, but at the end, contains exactly what I was expecting. Now that's good. And I'm using the fake. So, but I trust the fake. So this gives me confidence, speed, and low cost. And the key here is that I'm verifying the complicated thing in two different ways. I'm verifying the SQL database, and I'm verifying the in-memory database using the same test suite. So I know that they are functionally equivalent, and therefore I trust the fake. And therefore I can, and I do use the fake in this case for an acceptance test. So can we trust this? Well, I think we can, but let's look at an idea that Oscar Kelly shared with me. He's the author of Cucumber. A couple of years back, we were sitting, we had a course and we were sitting afterwards and discussing things. So let's imagine an application. It has a def as in the technology stack, as in web interface, all the way down to database. We have functionality on the other axis. And what I want to say here is that in my world, as a developer, when I say an end-to-end test, I mean we go from the edge of the system to the database, and I'm happy. That's an end-to-end to me. But if I were a tester, then that would not be enough, because the tester, they don't see an end-to-end that way. They see an end-to-end test as we do a business process, we verify a business process, which can and often do hit the database many times. So if I'm looking at an end-to-end test from my perspective as a developer, I'm happy with one case. As a tester, I need all the functionality of the program to work like this. So that's an area. And can we trust this? Yes, I think we can. But if we cover the same area in another way, by lots of patches, I think we can trust lots of tests at different levels that test different things and combined make out this area. So therefore, I think the idea of testing things using fakes in some situations, using the real thing in some situations, and sometimes test the entire technology stack is trustworthy. This is an image of the Brooklyn Bridge in New York. There is not one thing that holds this one together. There are probably thousands and even more small parts that all play their part. You can look at these cables, for example. There's a lot of cables hanging here. No, they're not hanging. They're actually stretched, and they are lifting this bridge. Each and every one of them is important, but if one fails, it's not a catastrophe. So this is how bridges are holding together. And I think that this analogy works in software development a long way with unit tests or integrated tests. So can we trust the patchwork? I think we can. I trust it. We're going to look at some code a little bit, some production code in a minute or two, where we do continuous delivery. And if I didn't trust my tests, I wouldn't dare to do continuous delivery. So, talk is cheap. Show me the code. That's a quote from Linus Torvalds, the father of Linux. So this is a project that I'm working on. I've been doing so for a couple of years. We have lots of parts, and I'm especially interested in looking at, just look at my cheat sheet here. Yes. So let's look at a test that checks for password when you want to change password. Post change password controller test. Oh, that's a mouthful. So this one is an example where I use a mock to verify. Sorry, I should make sure that it's easy to read, and the presentation mode. There we go. I hope this is easy to read. This is an example where I verify that this thingy, which is a service, it does important things to us, can be connected through a controller. So I'm creating a controller, I'm feeding the controller stuff that it needs, and I fake these things. In-memory user service is an in-memory implementation of this user service thingy that is important. And then I verify that we get a proper response back, that the password service has been called with a request to change password for this particular user. And now I'm happy, because I know that this one is being called. I know that this password service is connected in the controller. So this one is fast. We could run it and see how fast it is. Let's see if I can do that. Yes. It's Java, and Java is very slow to start. So 234 milliseconds and one test pass. I think we have a little bit more than, say, 1100 unit tests or something in this particular project. It takes 2 minutes to build. Way too long time to show here, but we have a lot of things. So this is an example where I verified interaction, and I'm happy with that, because now I know that if I just can make sure that this password service actually works as we want it to work, then this will be connected. At the heart of this system, we store stuff. So I'm going to look at one other case where I used a fake to drive the implementation. And here we go. This is a system where you store events as a medical doctor. This person, Bo, is a medical doctor, or it's our persona. And this one verifies that the few things has been called, the response has been called properly. We got the correct status code back, content type, and things like that. But it also uses a fake in this particular case. Not the real thing, but a fake. Can I see that here? No, I can't, but I can see it here. So this one, it's a controller, and it wants to store things in something called event service. An event service is something where we can store events, and whatever an event is, that's not important. But I'm using an in-memory implementation here, and I have a convenience method to make sure I can get it. So in this particular case, I'm using a fake to drive the implementation. So I'm sometimes using fake, sometimes using mocks. Turns out for me that fakes are sometimes much easier, because I don't always know what I want when I start. So using fake in this particular case is okay, if I can just make sure that I can verify the fake properly afterwards. And in this case, the final thing that is faked here is the database. So the in-memory event service is using an in-memory event database internally. But I can verify that I can log things, store things here, and that I can get them back. That's the most important part here. And this is fast. Let's run this one and see what happens. 390 milliseconds. That's an eternity. That's very, very long. But that's just the first one. If I ran 10 of these tests, and it will be really fast. So this is something that I use, and for I think that I'm allowed. Right, so let's get back to this. The architectural pattern that I've been talking about is referred to as ports and adapters. So when you Google this afterwards, ports and adapters is something to Google for. But it's also known as another type of architecture, but I forgot that I had this reference to port. I don't know if you're a sci-fi fan or not out there, but this is the port in Stargate SG-1. I'm not a fan of sci-fi myself, but I've seen that my girlfriend is looking at this one, so I thought that was probably a good thing to refer to. Maybe not, I don't know. Never mind. We have some kind of port into the system. We have some kind of adapter that talks to the system. What we saw in the code that I showed you was where we talked to a controller. Controller would be sitting at the edge of a system, or at least at the edge of a bounded context somewhere. But this architecture style is also known as hexagonal architecture, and that's perhaps a better name for it. I don't know. It can be described like this. We have some kind of shape indicating different areas of our system. We have some kind of way to get into the system. This could be a controller. In this, we often refer to this as the model. Internal. These dots, they know about the ugly world outside. They only know about the cozy part where we talk about the business problem. Then we have something that can talk to the port. Maybe many of them. Maybe there is a web interface. Maybe there's a mobile app using the same controllers, REST API, or what have you. And then we have something that can talk to the ugly world outside. This could be a queue, this could be a database, this could be something outside of this cozy part in the middle. And the ports are using or being used from the inside. So the port knows about the inside doesn't know anything about this port. However, it does know how to store stuff. It doesn't know how to do it, but it knows that it can be done, and therefore it can delegate to a port that can talk to, say, a database. So back one, they are addressed. Many of them. This architecture was the name was a guy called Alistair Cockburn came up with this, and he wrote about it back in 2005. The idea is older than that, but I couldn't find any good source that can tell me exactly when he introduced this. But yeah, he wrote a blog post, and it has unfortunately. It's not possible to find it anymore because his website is not up and running. I have found it through services that looks at the internet from a time scale, but you can't easily find this one, unfortunately. But Alistair Cockburn 2005 hexagonal architecture. So this is nothing new. It has been around for some time. Some people are trying to mimic the idea, and they call it onion architecture or similar things. But the main point here is that we have layers that can talk to layers. Then they can have almost any shape they want. And there's also an anecdote why it's called hexagonal. And it's a very simple answer. It's that all other shapes were already used. So therefore, Alistair had to come up with something new. And why not use a hexagonal? It works. So with configurable dependencies, we can get speed and low cost. You don't have to run everything from end to end, no matter if we're talking about my view of end to end as a developer, or if we're talking to testers or using the tester's view of end to end as in a business process. We can get confidence. We can make sure that it's fast and it doesn't cost us too much to implement. So my conclusion today, and I'm going to look at my conclusion today, is that we want to maximize the work not done. We shouldn't automate stuff that doesn't need doing in the first place. We need to take control of the world, and we should focus on confidence, speed, and low cost. Remember the testing pyramid. Manual things are important. You can't skip that. You have to start the application then and run it. But you can come a long way with fast unit tests. And hexagonal architecture can help you with testing, and you can create confidence, speed, and low cost by using fakes in a good way and trusting the fakes. And laziness wins in the end. A good friend of mine, Victor Olsson, coined that phrase, I don't know, a couple of years ago. He's also a developer, and he likes to automate stuff, and therefore he thinks that he's very lazy. But if you automate things, you're not lazy, you're smart. So Thomas, currently in Finland, and this example is available on GitHub, and you have the URL in, and here is the code. So if you're interested in this example, you can download it and play around with it. So I think that's actually all from me. Do we have any questions? How do I know if we have any questions? I have no idea.
I
Hold on.
think this is where we come into to the picture.
Okay.
Yeah, there were some here and then.
try.
There were some issues with the connection, but I think all in all, it was understandable. I mean, there were moments when it froze for just a bit, but I think it's fine. I had a question, for instance, about this test-driven approach, because you said you're also developing, but you're also mentoring. It's part of your activities. How do you introduce this approach? For instance, if you have a team that doesn't practice it or it's not used to do it, but they want to get into it, how do you introduce these practices?
I would probably, I've never done it, introduced it to a team like that, but I would probably sit with the team. I would probably try to do mob programming, and I would try to implement one example in a very small part of the system where we can see that, hey, this seems to be working. But I would want to use more programming, so the team is all in the team is there and are able to follow and understand. And then I would like them to implement an example themselves. I would be happy to steer them, but I wouldn't want to push an example onto them. I would try to lure them into implementing it themselves.
All right, and probably this is the
introducing it using programming. So now I'm quiet and I'm hoping that there's more questions. Or was it a comment? I don't know. I'll stop my video and see if it works better.
Yeah, let's try it like that. Maybe it's less traffic. To follow up on that, yeah, probably this is a classic question because yeah, there are different flavors of TDD, at least two main ones. Do you have a preference? And probably it's...
Yes, I have a preference. I'm definitely a mockist, if you want to use that word. I like the idea that Steve and Nat came up with some 10 years ago. No, a bit more, 2009, I think it was, when they wrote the fantastic book called Growing Object-Oriented Systems Guided by Tests, also known as the Goose Book. So that's Nat Price and Steve Freeman. Yeah. Working outside in. That's my preferable way.
Right, and yeah, because yeah, I think there are a lot of people who yeah either try different approaches, and each one has its probably pros and cons. Also saw a lot of people who started with the inside out because it was easier to tackle various entities first, but then I think also migrated to an outside in approaches later on once they got a taste for it.
Yes, and even though I prefer working outside in, I try to use the tool that helps me best in the given situation. So the classical approach with the Chicago School of Test-Driven Development, I definitely use that one a lot as well. It's not a war. This one is better than that one. They are different tools, and they have different pros and cons. But if you ask me which I prefer, I have an answer.
Perfect. All right, Thomas, thank you very much. Also a bit short on time. Appreciate you doing this talk, and then yeah, see each other next time. We'll see in what format, whether it's online or in person.
Yes, I would very much like to see you in person, and I'm very grateful for you having me, and thank you very much. If anyone is interested, feel free to contact me on email, thomas@thinkco.se, and yeah, thank you very much. Bye.
Thank you as well. Bye, Thomas.
Bye.
So after a short break, we'll resume again with Jakub.
It's 2 minutes this time. 12 minutes this time.
12.
It's more than 2.